Hey, seventh graders, this is Miss Richardson. I am on a field trip with the sixth graders today, so that's why we are not having live Zoom, but thank you for watching my video. I know you'll enjoy it so much. All right, so today we're going to look at inequalities. So instead of having equal signs in our problems, we're going to have these types of signs that you see on the screen here. So of course, you guys are familiar with these signs. You've been looking at them for probably 3 or 4 years now, at least. So this sign, we call that greater than, less than, and then these two, you would either say greater than or equal to, and the last one is less than or equal to, okay? All right, so here we go. Those were our math standards. This is our learning targets. So an inequality says that two things are not equal. So if you have a solution set, that means every number that would make an inequality true, okay? So let's look at this one in red right here. So we would say this, x is greater than or equal to 5. So what would be a solution to this inequality? Is 6, if I've made x equal 6, is 6 greater than or equal to 5? Yep. What about 10? Is 10 greater than or equal to 5? Yep. What about the number 5? Is 5 greater than or equal to 5? Yeah, so our solution set is any number that is 5 or higher, okay? All right, so let's look at this one in yellow. The way we would say this is 12 is less than or equal to 7. That is true. Obviously, 12 is not equal to 7, but it's less than 7. Right here on the bottom, we would say this 2 is greater than x. So you have to memorize the directions that these point if they're greater than or less than, okay? And then the blue one, x is greater than 1. All right, so here is a video. It is 6 minutes. So as you start your exercises, if you need some extra review, come back and watch this wonderful YouTube video. All right, so here we have a chart. It says, if true, circle true and continue across the row. If false, circle false in the second column and proceed to the next one. So you guys pause the video and give this a try and then come back to the video and see if you were right. All right, so the first inequality, 1 is less than 4. Is this true? It is true. Add 3 to both sides. So 1 plus 3 is 4. And 4 plus 3 is 7. Is that still true? True? Yep, it is. All right, what about the next one? -4 is less than 6. If this is true, yes. Now I'm going to subtract 3 from both sides. So -4 minus 3, that would be -7. -7 is less than 3. Is that true? Is -7 less than 3? Of course it is. -1 is less than 5. That is true. Multiply both sides by 2. So -1 times 2 is -2. 5 times 2 is 10. Is this still true? It sure is. -3 is less than 3. That is true. Multiply both sides by -2. -2. So what's -3 times -2? That would be +6. And 3 times -2 is -6. So is this still true? Is 6 less than -6? No, it is not. It is false. Did you guys get that one right? Did that one trick you? What about -2 is less than 10? Is that true? It is. Divide both sides by 2. So we're going to divide both sides by 2. So -2 divided by 2 is -1. 10 divided by 2 is 5. So do we still have a true statement? Yes, we do. And then the last one, 2 is less than 8. That is true. Divide both sides by -2. Divide both sides by -2. 2 divided by -2 is -4. 8 divided by -2 is also -4. And so now, is this a true statement? It is not. -4 is not less than -4. It's equal to. Okay, so as we proceed through inequalities, one of the rules is going to be when you divide or multiply by a negative number, you have to flip the inequality sign. So hopefully you'll remember this example. This is why. That's why in inequalities, when you multiply or divide by a negative number, you must flip the sign. Okay, but we'll get onto that. We'll get into that more next Monday. All right, let's move on. Hope you got all this right. All right, so we would read this. The value of x is less than 2. So what does that look like on a number line? Well, if we go to the 2 on a number line, x is not equal to 2, but it's equal to any number to the left of 2 on the number line. Make sense? The next one says a is greater than or equal to -2. So that means a can be -2 on the number line, or any number to the right of -2 on the number line. All right, now you guys try. I want you to pause the video and I want you to read these out loud. It's okay if you talk to yourself. Everyone does it. I want you to read these out loud to yourself or, in your room. And then I want you to listen to me say them and make sure you have said those right. All right, the first one, z is less than or equal to 1. The second one, k is greater than or equal to -5. The next one, d is greater than 0. And the next one, y is less than 8. All right, so here is a Brain Pop video. I encourage you to watch it and then afterwards take the quiz. You'll have to open Brain Pop in your launch point before you can click on this image to open it. It won't work if you don't do that. All right, so when we graph inequality, sometimes we fill in the dots. When we put our little dot on a number line, sometimes we fill it in. I call it a closed circle. And sometimes we leave it empty. The dot, we leave the circle empty, and I call that an open dot. Okay, so we're going to practice graphing inequalities. So hopefully you guys will write these down with me as we go through. All right, so on a graph, if I say, first of all, the first one is not an inequality, it's an equation. X is equal to 2. So the only value of x is 2. That's it. No other values will make this true. So the rest of them, we're going to have a very, very large solution set, actually an infinite number of solutions in all of these, but we're going to represent them on graphs by graphing them. So the value of x is either greater than or equal to 2. So on our graph, we would come to 2, we'd fill in the circle, and then we would say that x could be any value to the right of 2 on a number line. So that's why our arrow is pointing to the right. That means x could be 5, x could be 10, or any number greater than those, and it would make this inequality true. The next one says x is less than or equal to 2. So we find 2 on our number line, fill it in because x can be 2, or it can be any number to the left of 2 on the number line. The next one, x is greater than 2. So we're going to start at 2, but we don't fill in the circle because x is not equal to 2, but it could be equal. X could be 2.1, 2.2, so on and so forth. So any number to the right of 2 on a number line. X is less than 2. Once again, don't fill in the circle, but the arrow points to the left. And the last one, you won't see that very often. But for an example, if the only thing x is not is 2, that means x could be anything on the number line except for 2 itself. Now, I want you to pay attention when you're graphing. If your variable is on the left side of your inequality, if it's on the left side, your arrow will always match your inequality. See what I'm saying? If I made this symbol right here an arrow, it would point to the right. Well, that's exactly what's happening over here. You see what I'm saying? All right, if I made this an arrow, it would point to the left. Well, that's what's happening right here. We're pointing our arrow to the left. Same thing, our arrow points to the right. And here our arrow points to the left. So as long as that variable is on the left side of the inequality sign, your arrow and your inequality sign will match. So that's the easiest way to figure out how you're supposed to be graphing these. All right, so let's practice. I hope you guys could sketch these, at least if you can't print this page out. All right, so we're going to find 2 on our, I'm sorry, not 2. We're going to find -1 on our number line. Are we going to fill it in or leave it open? Well, if it doesn't have the or equal to sign, you have to leave it open because x is not equal to -1, but it's less than -1, which means we're going to look at our inequality sign that looks like an arrow pointing to the left, and that's where we draw our line. The next one says x can be x can be 4 or any number greater than 4. Okay, so x could be 4 or 5 or 6 or 6.5 or 7.25, so on and so forth. So we're going to go to 4. We're going to fill that circle in, and this looks like an arrow pointing to the right. Arrow pointing to the right. The next one, x is greater than -6. Can x be -6? No, but that's where we start. We leave that circle open, leave it open, although it looks like I was starting to stop it. Stop, just stop writing. And then we're going to make our arrow go to the right. The next one, x could be 0 or any number less than 0. So find your 0, fill it in, and your arrow is going to point to the left because that's what our inequality sign shows us. Now let's look at the last one. Just remember, if the inequality sign is not on the left, the arrow and your inequality sign will not match. Okay, so what the first thing I do if I see a problem like this, first thing I do is I flip the whole thing around. If -6 is greater than or equal to x, that means x, got to flip this thing around, will be less than or equal to -6. You can't just rearrange the 6 and the x. You have to flip this whole thing around, okay? These two statements now match. And now when I graph it, since my variable's on the left, I know exactly which way my arrow points. Okay, to the left, to the left, to the left, to the left. That should be a song. What should write a song about to the left, to the left? All right, so now we know how to graph. Now we're going to start solving inequalities. Solving inequalities are the same exact steps as solving equations. Sometimes my brain forgets what I'm saying. Yes, solving inequalities are the same exact steps as solving equations. The only difference is instead of writing equals, 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 you're writing your inequality sign. So here's our first example, x plus 12. I did not mean to do that. X plus 12 is less than 60. So just like if this were an equal sign, we have the same goal. The goal is to get the variable by itself. So just as if this were an equal sign, we're going to get rid of plus 12. What's the opposite of plus 12? Minus 12. So that's what they do here. They're bringing that inequality sign down. So x instead of equal to, what I'm writing up here because I'm doing an equation. The only difference in our answers is they bring that inequality sign down instead of equals. And then you're going to graph it. So we find 48 on our number line right here. Very small. We do not fill it in, right? And then our arrow points to the left because our our variable is on the left of the equal sign. Excellent, excellent. All right, pay attention to the sign. Since the sign below is a less than sign, plot the open circle because it doesn't have the or equal to symbol on it. And then we did all of that. Awesome. All right, what about this one? Well, our x is on the right side of the equal sign, or the inequality, I should say, which is fine. We're still wanting our x by itself. So what is over there on the side with x? Minus 5. What's the opposite of minus 5? Plus 5. Plus 5. So then we bring that x straight down. We bring our inequality sign down. And 3 plus 5 is 8. So 8 is greater than x. The same thing is x is less than 8. If the small point points to the x here, the small part has to point to the x on the bottom one. Okie dokie. And so, of course, to graph that, we would have our number line. We'd have 8 here. We'd have an open circle because it isn't equal to x. I'm sorry, it's not equal to 8, but it's any number to the left of 8 on a number line. There it is. Now graph it. That's what we did. Yep. Now that the variable's on the left, you can follow the rules. Less than, open circle, so on and so forth. All right, how are you guys feeling about that? All right, so this is going to be my last slide for the day, but I want you guys to write these 4 problems down with me, or do it, you know, on your paper, and then I want you to pause the video. I want you to see if you can not only answer these, solve them, but also graph them, okay? Because you have to do that tomorrow on your own in your math problems. All right, did you solve them on your own? I hope you did. So number 1, we want x by itself. So on the side with x, we see -2. So we're going to add 2 to both sides of the inequality. X is greater than 6. We go to 6, open circle, and our arrow points to the right. And I hope you got the same answer I did. Number 2, what is going on with x? X is being divided by 3. What is the opposite of dividing by 3? It's multiplying by 3. We're going to multiply both sides of the inequality by 3. So those 3's are gone. We bring down our x. We bring our inequality sign down. And x, 7 times 3 is 21. So x could be 21 or any number less than 21. So we're going to find 21. We're going to fill it in. And our arrow points to the left. Number 3, this is 6 times x. What's the opposite of times 6? Divided by 6. Divided by 6. We bring that x down. We bring down our inequality sign. And 30 divided by 6 is 5. So we find 5. We leave an open circle. And our arrow points to the left. And the last one, x plus 9. What is the opposite of plus 9? Minus 9. Minus 9. So we have x is greater than or equal to 2. So we're going to fill in that circle and our arrow points to the right. All right, I don't know why I didn't have 2-step inequality, so let's try one. So write this problem down as well. So 2x minus 4 is greater than, I don't know, negative 2. All right, write that down, write that down, write that down. All right, so we want x by itself. So we're going to go to what's over here on the side with x, -4. What's the opposite of -4? The opposite of -4 is +4. +4. All right, so now we have 2x. We bring our inequality sign down just like we see it. What's -2 plus 4? -2 plus 4 is 2. And now we see x is being multiplied by 2. What is the opposite of multiplying by 2? Dividing by 2. Dividing by 2. This is gone. We have x by itself because 1 times x is x. So our final answer is x is greater than 2 divided by 2 is 1. So we would come down here on our number line. We would circle 1 without filling it in. And then we would point our arrow to the right. All right, you guys, thank you so much for watching my video and doing what you're supposed to do. So now you should be able to do your assignment for Thursday, and then on Monday, we'll pick up the rest of these. Okay, guys? Everyone have a great day. I will see everyone later. Oh, there's my video over there. Bye, guys.